Okay, today we're going to talk about how do you find the equation of a polynomial given its zeros. So there's three basic steps in doing this. The first thing you're going to do is at every zero, you want to convert it into a factor that's in the form x minus a. Then you're going to multiply all of the factors that you have and then write the polynomial in standard form. And then just for this one, make sure that it is of the correct degree. So they are going to tell you the degree in the question. So right below it is our example. It says find the polynomial with the given zeros, multiplicities, and degree. So since it's telling me that it's degree 3, that means that when I finish this problem, I'm going to have to double check that I have somewhere in my polynomial x to the third power. And then they even gave us a graph of what our function should look like. Our first zero is x equals -4. So if you look at the graph at -4, it is touching the x-axis. But because it has a multiplicity of 2, so meaning it's even, it bounces off that number. The other zero we have is -1. So again, it does touch at -1. Its multiplicity is 1. That's an odd number, so that means that it goes through that number. Okay, so now my goal is I want to find the equation of that function. So if I follow the steps from above, the first step said to convert each zero into a factor of the form x minus a. So the first zero, I'm going to label it, that way I can keep track of everything. So let's say that's number 1. I want to convert that into a factor. So if I have x equals -4, I want the x and the 4 to both be on the same side of the equal sign. So I'm going to add 4 to both sides. So that gives me x plus 4 equals 0. So my factor in this case is just going to be x plus 4. Now it said in the problem that they gave us that it has a multiplicity of 2. So that just means that my factor is going to be squared. So that comes from the multiplicity. Okay, now let's do the other zero that I have. So I'm going to call this zero number 2. So in that one, I have x equals -1. So again, I want the x and the 1 to be on the same side. So I'm going to add 1 to both sides. That gives me x plus 1 equals 0. So my factor here is x plus 1. So I'm going to go back up really quickly. In our problem, they said that it has a multiplicity of 1. So that factor is to the 1 power. Only anytime you have 1 as an exponent, you don't really need to write it. So I'm going to take that off. So what's important here is this is one factor and this is the other, and those are coming straight from the zeros of the function. Now going back here, we've done step 1. Step 2 says to multiply all of the factors. So I'm probably going to run out of space. I'm going to have to work down here. So next thing is to multiply all the factors. Since this is a function, I'm going to call it f of x. The first factor was x plus 4 to the second power. And then the second factor was x plus 1. So now I want to multiply this all out. I'm going to start by only doing this part that I'm putting in green brackets. So let's start by multiplying that first. So I know that when something is squared, it's technically there twice. And then I'm just going to bring down that last factor. So again, I am still only looking at these two for now. I want to multiply those binomials. You could use FOIL or you could use box method just to keep it kind of more visual, and I think it's easier to understand. I'm going to do box method. Okay, so I have x plus 4 times another x plus 4. So if I do corresponding column and row, I have x times x gives me x squared. Then x times this bottom 4 gives me 4x. If I do the top right, 4 times x is 4x. And then now that bottom left, or I'm sorry, bottom right, I have 4 times 4 is 16. So now I'm going to write it in my function, but I'm going to combine like terms as I go. So I have x squared, that's the only one that's squared. Then I have plus 4x plus another 4x. So together that would make plus 8x, and then plus 16. And then bring down my other factor, x plus 1. So we've got 2 of these factors multiplied. But now I need to multiply that last factor, that x plus 1. So again, I'm going to do box method again. It's just that this time we're going to need a bigger box. This one needs to be a 3 by 2. So that first one, x squared plus 8x plus 16 times x plus 1. Okay, so let's do the top row first. So up here. X squared times x gives x to the third power. 8x times x is 8x to the second power. And then 16 times x is 16x. Now for the bottom row, x squared times 1, 8x times 1, and 16 times 1. Anytime you multiply by 1, it's just going to stay the same. So I'm going to just rewrite x squared plus 8x plus 16. So just as we did before, I'm going to combine like terms as I take it out of this box. So there's only one term that has x to the third power. But then I have 2 terms that have x squared. So that's 1 plus 8 would be 9. So plus 9x squared. Then I have 2 terms that have x. Whoops, I meant to highlight. 8 plus 16, that gives me 24. So plus 24x. And then last, that's the only regular number. So plus 16. So I'm just going to double check back at the original top problem. It said that we should have a degree of 3. And we do, because we have x to the third power. So that is our function that matches that graph with the given zeros and multiplicities. Okay, guys, I'm going to give you one problem that looks like this and have you guys turn it in to me today. If you have any questions over anything, just please let me know.